Hello everybody, this is Shilpa Gogre from Department of Mathematics, Maharishi Dayanand College, Mumbai. Today we shall see the prerequisites for the topic probability. The first concept which should be known is that of factorial. Now factorial is defined for natural numbers and it is denoted by n factorial. So n and this exclamatory mark is given and it is defined as n into n minus 1 into n minus 2 into n minus 3 up to 3 into 2 into 1. So you start with n and go on reducing that number and multiply all those numbers. Note that 0 factorial is defined as 1. Let us see the examples. For example, 3 factorial is 3 into 2 into 1, which is 6. Whereas 4 factorial would be start with 4 and go on reducing the number. So 4 into 3 into 2 into 1, which is 24. You can also see that 4 factorial is 4 into this 3 into 2 into 1 is actually 3 factorial. So it is 4 into 6, which is again 24. The second concept is of combination. Now combination is defined as number of ways in which R objects from given n objects can be selected. It is denoted by NCR. So C is capital. On the top left hand side you write small n, and at the bottom on the right hand side you write R and read it as NCR. It is defined as follows: NCR is equal to n factorial upon n minus r factorial into r factorial. So this is the formula for NCR. For example, let us see how to compute 3C2. 3C2. What you mean by 3C2 is two objects. It is the number of ways in which two objects from three objects can be selected, and using the formula we get it is as 3 factorial upon 3 minus 2 is 1 factorial and r is 2, so it is 2 factorial. So what we get is 3 factorial upon 2 factorial. 3 factorial is 3 into 2 into 1, 1 factorial is 1 and 2 factorial is 2 into 1. So when this get cancelled, the answer is 3. Other way of doing the calculation is 3 factorial can be broken as 3 into 2 factorial. Denominator is 2 factorial, and then you cancel this 2 factorial and the final answer is 3. Let us see one more example. 5C2. So using the formula it is 5 factorial divided by, you have to do 5 minus 2, that is 3 factorial into 2 factorial. Now because you have 3 factorial in the denominator, you break this 5 factorial in the numerator as 5 into 4 into 3 factorial divided by this 3 factorial I keep as it is because it is going to get cancelled from the 3 factorial in the numerator, and 2 factorial is 2 into 1. Normally we don't write 2 into 1, we simply write it as 2 because anything multiplied by 1 gives you the same answer. Now here this 2 factorial gets cancelled, 3 factorial gets cancelled, and then reducing it we get 2 1s are 2 2s are. So 5 into 2, that is the answer is 10. Now let us see the third concept, that is of permutation. It is the number of ways in which R objects taken from N objects can be arranged. So remember, it is the arrangement of the objects. It is denoted by NPR. So you have a capital P in between. On the left hand side top you have small n, and on the right hand side bottom you have R, and it is read as NPR, and it is defined as, see the definition is this: NPR is equal to n factorial upon n minus R factorial. Let us see example. 3p2, by definition it is 3 factorial upon 3 minus 2 factorial, that is 1 factorial. So it is 3 factorial. 3 factorial is 3 into 2. As I told you, we don't normally write into 1 because it doesn't make any difference. 3 into 2 into 1 is same as 3 into 2, and so the answer is 6. If we want to calculate, let's say 4p1, then it would be 4 factorial upon 4 minus 1 is 3 factorial, and 4 factorial upon 3 factorial, how do we compute? We break 4 factorial as 4 into 3 factorial, because we have 3 factorial in the denominator and it can get cancelled with the 3 factorial in the numerator. Therefore, we break 4 factorial as 4 into 3 factorial, and in the denominator you have 3 factorial. This 3 factorial gets cancelled and the answer is 4. So these are the 3 concepts which can be used for solving the problems on probability. These remarks can be remembered while solving the problems on probability. So the first remark is NC0 is 1. So for any natural number, if you have something like NC0, you can directly write the answer as 1, whereas NC1 is n and NCR is same as NC n minus R. Now for permutation, similar formulae, NP0 is 1 and NP1 is n. So using these remarks, one can say that let us say 5C0, suppose I have, the answer is going to be 1. So these are few examples I am discussing. Or if you have 5C1, then the answer is 5. If you have 5C3, then it is same as 5C 5 minus 3, that is 2. So 5C3 and 5C2 are same, using the third remark over here. Now some more examples for practice are required to be solved. For that, please check the Google form link which is given in the description box below this particular video. So solve the problems and select the correct options. It is an MCQ Google form. So that will give you the clear idea whether you have understood these prerequisites, which are very, very essential for solving problems on probability. Thank you.